In this video, we will do a brief overview of chemistry. The first question we have to ask is, what's the matter? So matter is anything that occupies space and has mass. Matter is the substance of our universe, from the smallest grain of sand to a star you see in the night sky. Matter is made up of elements, and you see these listed on the periodic table. And the most abundant elements in the human body include oxygen, carbon, hydrogen, and nitrogen. An atom is the smallest quantity of an element that retains the unique properties of that element. So for example, an atom of hydrogen is a unit of hydrogen, the smallest amount of hydrogen that can exist. Atoms are made up of even smaller subatomic particles, which include protons, neutrons, and electrons. Some elements will have isotopes. So these are different forms of an element where there are different numbers of neutrons. So you can see in this picture isotopes of hydrogen with 1, 2, and 3 protons, respectively. Some isotopes are radioactive. This occurs when the nucleus of an isotope can readily decay. And when it decays, it can give off subatomic particles and electromagnetic energy. Excessive exposure to radioactive isotopes can damage cells and can even cause cancer and birth defects. But sometimes it can be useful in medicine if this exposure is controlled, and so this would be something like interventional radiology. Now we'll talk about chemical bonds. A bond is an electrical attraction that holds atoms in the same vicinity. A bond can be weak or a bond can be strong. You will have bonds between two elements, and so you can have a molecule where two or more atoms are held together by chemical bonds, such as hydrogen gas. And you can also have compounds. And so a compound is a molecule made of two or more elements. So one example of a compound is water, where you have 2 units of hydrogen and 1 unit of oxygen. We'll talk about 3 types of bonds. We'll talk about ionic bonds, covalent bonds, and hydrogen bonds. So an ion is an atom where there's an electrical charge, such as potassium. There's 2 types of ions. There's cations. These are ions that are positively charged. So for example, you have sodium or magnesium. You can see here with magnesium, it has a net charge of +2. So they're able to donate 2 electrons. An anion is a negatively charged ion, so this would be something like chloride or selenium. And you can see here, selenium has accepted 2 electrons, so it has a net charge of -2. An ionic bond is an ongoing close association between ions of the opposite charge. A great example of an ionic bond is sodium chloride. With sodium chloride, you have sodium, which is a cation, and chloride, which is an anion. And you can see in this figure where sodium readily donates this solitary electron in the valence shell to chlorine, which only needs 1 electron to have a full valence shell. And so now you have the opposite electrical charges of the resulting sodium cation and chloride anion will now result in this ionic bond. And you've used table salt, and so you see it's got that crystal structure. And so the attraction of a great number of sodium and chloride ions leads to these large groupings that we call crystals. Another type of bond is a covalent bond. In covalent bonds, molecules are formed by sharing electrons in a mutually stabilizing relationship. Because there's this close sharing of pairs of electrons, where you have one electron from each atom, covalent bonds are stronger than ionic bonds. You can see some common types here of covalent bonds. So in A, we have a single covalent bond like hydrogen gas, where two atoms of hydrogen will share their electrons in a single covalent bond. Oxygen gas here is an example of a double covalent bond. And so the oxygen molecules share two pairs of electrons. And then carbon dioxide is an example where there's two double covalent bonds, where carbon has a double covalent bond with two different molecules of oxygen. And then our third type of bonds are hydrogen bonds. So hydrogen bonds are formed when a weakly positive hydrogen atom here that's already bonded to one electronegative atom, like the oxygen here, is attracted to another electronegative atom from another molecule, like this oxygen in water. So you can see this is how water molecules will bond together, is hydrogen bonds between a hydrogen ion on one molecule water and an oxygen ion on an oxygen molecule, and the other ones will form this hydrogen bond. Because of this property, water molecules strongly attract charged molecules and ions, and so this is why salts like sodium chloride will dissolve in water. Water molecules also repel molecules that have non-polar covalent bonds, and so this is why things like fat, lipids, and oils don't dissolve in water, but they form beads because of this nature of water. And the last thing we'll talk about here is chemical reactions. So a chemical reaction is a process where there's a rearrangement of either a molecular or an ionic structure of a substance without a change in the physical form or some sort of reaction with the nucleus. There's three general types of chemical reactions. At the top here, you can see a synthesis reaction where you have substance A and substance B, and then they form the substance AB. You can also have a decomposition reaction, which is the opposite, where you have substance AB is then broken down in substance A and then substance B. And then you can have exchange reactions. So there's two examples here where you might have a substance like an AB, and then it can exchange with another substance to become something like AC here, where you just got AB plus C. Or you can have AB and then CD in an exchange reaction, where then the AB compound exchanges B for D, and the CD compound exchanges D for B, so they just swap. And then finally, we should discuss some factors that influence the rate of chemical reactions. So the first thing to think about is the properties of these reactants. So what is the size of the reactant? Something where there's a more of a surface area will have more opportunity to have reactions, and so that will increase that rate of reaction. There are different reactivity features of different reactants, and so some may have a higher reactivity and would have a faster rate of chemical reaction. And then the state of a reactant, is it a solid, a liquid, or a gas? Temperature is an important consideration. So reactions happen at higher temperatures for nearly all chemical reactions. And so because kinetic energy is that matter in motion, the higher the temperature, the higher the kinetic energy, and so the more likely they're able to come into contact with their reactants. Concentration is something to consider. So if you have a higher concentration of particles, that reaction is more likely to happen, and so it will happen at a faster rate. And then finally, in nature, we tend to or at least in the human body, we tend to have enzymes and catalysts that control the rate of reaction. So a catalyst is any substance that increases the rate of a chemical reaction without undergoing some sort of change itself. And so the most important catalyst in the human body are enzymes, which is a catalyst that's made of either protein or ribonucleic acid or RNA. And so these enzymes work by lowering the threshold of energy that needs to be invested in a chemical reaction. So you can see in this graph here. And so with this enzyme, it's going to happen at a much faster rate because you don't require as much energy to get it started. So this was a very brief overview of general principles of chemistry.